Welcome back. So in the examples of hypotheses that we just saw, there was some notation here, H sub 1 and H sub 0, and we didn't talk about what this null hypothesis is. So let's talk about some of those details of vocabulary and notation. The null hypothesis, which we're always going to denote H sub 0, and that's actually more conveniently read as H naught. So you'll hear me refer to this as both H sub 0, H naught, or just the null hypothesis. Anyway, it's a statement of no change or no effect or no difference. So it's a statement basically of the status quo. And it's assumed true, so it's our sort of starting assumption. It's assumed true until evidence or data, so evidence in the form of data is I guess what we deal with in statistics. So until it's assumed true until evidence or data indicates otherwise. The alternate hypothesis denoted H sub 1, or even just H1, is the statement we are trying to find evidence to support. So this alternate hypothesis is the one that you kind of think of as the hypothesis that leaps out at you from the statement of the problem. All right, let's go back in and fill in the null hypotheses so we can see the difference between the null hypothesis and the alternate hypothesis. Again, the null hypothesis is a statement of no change. So in this first example, the null hypothesis would be the claim or the statement that no, 80% of Americans still feel satisfied with the way things are going in their personal lives. In other words, that there has not been a change since 2008. So the null hypothesis is the statement that P, the proportion, equals 0.8. The null hypothesis will always have equals in it. So the null hypothesis will always be a statement of equality, okay? But the meaning of that equation will be that there's no change from the previous number, or in the next example, where the packaging on the light bulb states that the bulb will last 500 hours, the null hypothesis is going to be the claim that, yes, there's no difference between the actual mean and what the packaging states. So the null hypothesis is that the mu is actually equal to 500. Notice the null hypothesis has an equal sign in it. And our third example, that the standard deviation of the rate of return for a certain class of mutual fund is 0.08%. The null hypothesis is going to be that for this particular mutual fund manager, there's no difference between his standard deviation and the standard deviation for the broader class of mutual fund that his fund belongs to. Okay, and then the other thing we didn't fill in that section was types of tests. So, but notice that there's basically three sort of versions of null and alternate hypothesis that we've looked at. Now, the null hypothesis always has the equal sign in it. The alternate is going to be a statement that contradicts this. So it could be a statement that parameter, whether it's mean or proportion or standard deviation, the alternate hypothesis could be that parameter is greater than some value, or that it's less than some value, or that it's not equal to some value. And I think we saw one example of each in those examples that we're looking at right now. Now, when we go to test these, we'll be using various distributions. We'll start out using the normal distribution, and then we'll use the t-distribution, and then we'll use the chi-squared distribution. So we're going to be using the same three distributions that we did for confidence intervals, we're just in a different context here. Anyway, as you know, so the distribution, some kind of curve like this, if we're testing the hypothesis that parameter is greater than some value, so let's say here's the value, then we're going to be looking for the probability or area to the right of that value. Whereas if we're testing parameter less than something, so we're looking at the probability that the parameter is actually less than some value, then we would be looking at area to the left under whatever distribution it is that we're working with in that problem. And if we're testing the proposition or hypothesis that the parameter is not equal to some value, we're going to be looking at the area that's away from that value. So we're going to be looking at area out to the left and out to the right. And because of that, this type of hypothesis that is testing parameter greater, or stating that a parameter is greater than some value, that's known as a right-tailed test. Okay, we're looking at the right tail to test the hypothesis. If you're testing or investigating parameter less than some value, you're looking at a distribution like that. So this is called a left-tailed test. And if your hypothesis is that the parameter is not equal to some value, this is called a two-tailed test. So we don't say both left and right, we say two-tailed. And then similarly, if it's either right-tailed or left-tailed, these are both, either one of these is often referred to as a one-tailed test. Okay, so let's go back to our three examples of hypotheses and fill in the type of test. So in the first one, the alternate hypothesis was the statement that the proportion was not equal to something. So that's a two-tailed test. In the second example, the alternate hypothesis, it was a statement that this parameter, mu, the mean, was less than some number. So that's a left-tailed, because to the left, looking for things that are less means you're looking for things to the left. So that's a left-tailed test. And third, in example C, the hypothesis is that this parameter that happens to be the standard deviation is greater than some number, so that would be a right-tailed test. So you just look at whether it's less than, greater than, or not equal to. Then that tells you what type of test it is. Okay, so having gone through all that sort of terminology, I'm going to give you a chance to do the exact same thing with a few examples. So for each of the following, determine the null hypothesis H0, the alternative hypothesis H1, and the type of test. So here we go. A pharmaceutical company has just developed a new antibiotic for children. 2% of children taking a competing antibiotic experience headaches as a side effect. A researcher wants to know if the percent of children that experience headaches as a side effect when taking the new antibiotic is greater than 2%. So you're going to fill in H0, H1, and the type of test. Then do the same thing for build your understanding number 2 here. The Blue Book price of a used 3-year-old Chevy Corvette ZR1 is $86,012. A car buyer wonders if the mean price of this car in his city is different than the Blue Book price of $86,012. And number 3, the standard deviation of the amount of detergent placed in 64-ounce bottles by an old filling machine is 0.23 ounces. The detergent manufacturer wants to know if a new filling machine has less variability. And remember, standard deviation is what measures variability. Okay, please do take a shot at this Build Your Understanding problem before you come back and watch the next video. You learn so much more. Even when you can't do a problem, that's where you learn math and statistics, not from watching a teacher do it. So even if you run into a problem and aren't sure what to do, what that does is it still gets your brain digesting the material, digesting the terminology, digesting the approach. So it's okay whether it goes well or not. It's still helpful for you to do it by yourself. So don't be afraid of making a mistake or getting stuck. That happens to all of us when we're doing math and statistics. But that's where the learning really happens, is when you're grinding through something difficult, and then we'll come back together and go over it together. So I'll see you in the next video for that.